Welcome to UG Academy. In today's video, I'm going to continue on recursion. In the last video, I used Fibonacci sequence as an example of how recursion can make our code much simpler compared to using loops. However, in that example, recursion is actually very inefficient. So in this video, I'm going to use another example, which is binary search. In this example, recursion becomes much more efficient. Although it's still not more efficient than using loop, but it's already much more better than finding Fibonacci sequence. The idea of binary search is very simple. We have an array of numbers. This array should be sorted. So in this case, ascending order. And then we are going to be given a target number. And then we are going to return its index within the array. If it does not present in the array, then we are going to return -1 as its index. This algorithm can be implemented fairly easily using recursion. Okay, let's have a look. First, let's define the function. So it's an integer type return, which it will be the index of the targeted number, and then the data array, also the low and high, indicating the section of the array that we would like to search. Okay, corresponding to the first and last here. Then we are going to define a value which, in case that the number is not found, then we will return -1. So here is our first base case. If the upper bound of the array is smaller than the lower bound of the array, that is obviously invalid, which indicates that the number is not found, so we return not found. So this is our first base case. Okay, and then we are going to use binary search. The idea of binary search is that we cut the array in the middle here, and then we compare whether the target number is smaller than the middle here or larger than the middle here. If it's smaller than the middle number, then we change the high change the high number here, high index here, to the middle index, and then continue to search within this section of the array. And the other way around is the same. We change the low index number to the mid number, and then we search this section of the array. So we first calculate the middle number. Yeah, the middle index is literally not the middle number. And then we check if the middle number is equal to the target number we would like to find. So data middle. If it's equal to the target number, then we return middle number, this middle variable, as the index of that number of our target. But often it will not be the case. So we are going to continue our search. Here is where our recursion comes in. If the middle number is larger than our target, then we are going to search this section of the array. So how to do that? We call our B search again. However, this time we are going to pass our middle -1 as our high here. So it will start searching from here, this section, instead of searching the entire array again, which will be the same as our initial pass. So this is how recursion works. Of course, we use return because this binary search will eventually return the thing we want, so we directly return the result of the self-call. There is also other possibility, which in case that the number is in the upper half, then we do this one. Okay. Oops. So this time the high remains high, and then the low becomes middle +1. Okay. So this is how binary search works using recursion. I believe it's very simple to understand. The only drawback of this algorithm is that it requires that the data to be sorted here. Yeah. So let's have a look at the result. This main function here is a very simple example. So we just randomly create an array using initializer list, and then we calculate the length of the array. We get the size of x within the memory, and then we get the size of the element. After having some simple calculations, we can get the length of the x integer array. And then we pass in the array, pass in the lower index, which will be 0 in this case, because our index in C++ starts from 0, and then go to length minus 1, okay, instead of length. So we are first going to try to search for the 3. So it should return 1 here, because 0, 1. The index of 3 is 1, okay, within X. And then we are going to search for 4, which in this case is not present in the array. So it should return -1. Let's have a look at the result. I've already pre-compiled this program. So here, 3 return the index of 3, which is 1, and then 4 not present in the array, so return -1. Exactly what we expected. So that's all for today.